Hi, I'm Mike Coffey. I'm a field service engineer with Rush Machinery. Today I'd like to talk about our newest product, the RushCut. This is a fully enclosed machine to contain the fluid and for safety. This PLC stepper motor driven machine is proudly manufactured and supported by Rush Machinery in the USA. The RushCut is used by cutting tool manufacturers and regrind shops to provide a safe, effective way of cutting carbide and high-speed steel tools and rods. So the clamping, the pneumatic clamping is easily adjustable. You can just slide it into position, whichever position you want, either side. Usually you want to keep it pretty close to the blade. And then the stop is easily adjustable and has a thumb screw to tighten in place for an easy setup. The coolant lines are fed directly into the blade for cooling of the part and the blade. The aluminum extrusion with all its slots provides easily customizable tool holding or work holding. The HMI provides an easy setup. You can store your position. Move your joystick or the forward jog button to the position, the A position, and then you press your store position A. Then you move through the cut or jog forward through the cut and then store your position B. When you're finished, you can go to position A and then it's ready to begin your cycle. Go to auto mode, start cycle. Notice that the coolant comes on, the clamping comes down, the feed begins. After it's reached position B, it returns, the spindle stops, the clamps come up, and the coolant shuts off. In the quick cut settings, you can select your diameter of tool by using next settings or previous settings, and then load settings will put your feed rate in your positions in that you previously stored. Right here you would store your spindle feed rate. You can press what your maximum feed rate would be, enter, and then you can control a percentage of that speed to find the correct speed. Over here you can control your spindle speed, which has a range from 1760 RPMs all the way up to 2656 RPMs. These both can be adjusted on the fly. This here is our balancing machine made by MPM. This is one of the best values in the balancing industry. This machine sells for about $25,000. The return on investment in this it will be quick because you'll have longer tool life, you'll have a better finish on your tools. The longer the tool life, the less you have to dress the wheel and shape the wheel. As you know, diamond wheels are expensive, so prolonging the life of the wheel is going to save you money. Not to mention the bearings that you're saving the wear and tear on. I'm going to demonstrate a wheel balancing here. So the machine's been warming up. I'm just going to stop it. This uses a Microsoft operating system that you can store your wheels in. You can select the wheel. I'm using this wheel that I put all the data in earlier. Pneumatic canopy opens up. I'm using fixed position balancing here. There's multiple ways of balancing. You can use axial drilling, radial drilling, milling, fixed position, and split position. Split position would use either a nut with weights on it, or you can get this spacer that is movable and allows weight to be distributed in different spots with a set screw. I'm using a mark to indicate my zero position. I'm going to put this in at 0. Clamp it down, close the canopy, and start my balancing. We use an index method for accurate measurement. So when the first measurement finishes, it's going to tell me to index the part. It positions itself to the 180 degrees to index it to. I open the canopy, release the clamp, move my 0 position now at the 180 position. Close the clamp, close the canopy, check that I've indexed it, and now it begins its second measurement. After the second measurement, I can see that I have a G value of 40. That's about the same quality as the car tires, your car tires, about G40. We're aiming to get a much lower G quality, which is actually a higher quality, a faster rotation. So right now, you can see at 1,283 RPMs, we will begin to experience vibration. This is telling me to put a 2.1 grams at 92 degrees and 0.104 grams at 62 degrees. It's positioned me right at 62 degrees. I have a 2.2 gram weight that I'm going to move it to the 92 position and just put that in right there. If the hole is not threaded in that position, you can change positions with these arrows to go to the next hole that is threaded. I add the weight, close the canopy, start my second measurement. The quality grade that we're going for is 2.5, which all was set up in this menu. So these are the pages where you add your parameters. You add your test weight size, your pitch circle where you put your weight, and offset from the 0 degrees. If you're using spread angle, fixed position, milling, axial drilling, or radial drilling, you would choose the one you're drilling and put in your data for that, your parameters for that. Then over here you select your type that you're doing. We want the G value, we're doing a single plane. We got the drilling axially, drilling radially, and milling. All right, I'm indexing again. Check. We've only achieved 6.3 G. We didn't get all the way. We could do another iteration. However, if you look at 6.3, you can see that we're already at 4,800 RPMs that we can go to without experienced vibration. Most of your machines are probably going to be 4,000 or less. Thank you for viewing our video. You can check out www.rushmachinery.com to see more of our products. Thank you.